Today is January 24th, 2026. We are now looking at data that changes the entire conversation around 3I Atlas. For weeks, we have been tracking the post-perihelion behavior of this object, waiting to see how it would react to the intense heating of its closest approach to the Sun. The wait is over. New observations from the Solar and Heliospheric Observatory have just been released, and they reveal a feature that was completely invisible from ground-based telescopes. This is not just a standard cometary tail. What the all-sky Lyman Alpha camera on board the observatory has detected is a massive concentrated plume of hydrogen surrounding the object. Let's look closer at the data. This plume appeared just 9 days after perihelion passage on October 29, 2025, and was monitored continuously for 32 days. The volume of material here is staggering. The calculations imply the release of roughly 13.5 million metric tons of water during this short observation window alone. To put that into perspective, that is a quantity of water massive enough to fill thousands of Olympic-sized swimming pools, all ejected into space in just over a month. But before we simply categorize this as typical outgassing, we need to consider the implications of the specific composition. We are seeing hydrogen. This connects directly to the hitchhiking hypothesis we have been discussing on this channel. If you possess a technological civilization capable of interstellar travel, you do not haul your fuel across the galaxy. You harvest it. Water is the gold standard for this because it can be electrolyzed into hydrogen and oxygen. Together, those form one of the most efficient rocket propellants known to physics. What we are witnessing in this hydrogen data might not just be a passive sublimation event. We have to ask the uncomfortable but necessary question. Could we be looking at a refueling operation? If an object or a vessel hitchhiking on an object intended to steer itself toward a specific target, it would need to vent mass to generate thrust. The hydrogen detected by the Solar and Heliospheric Observatory represents exactly the kind of usable fuel required for such maneuvers. This is the crucial detail that separates 3I Atlas from the other interstellar objects discovered over the past decade. It is large, fast, traveling at over 60 km/s, and now we know it is shedding water at a rate that could support sustained propulsion. If you want to stay ahead of this unfolding story as we analyze these data points in real time, make sure you are subscribed to the channel. We are tracking every new release from the observational teams as they come in. So, what does this actually mean for the trajectory? If this outgassing is purely natural, it should be somewhat chaotic or strictly thermal, driven by the sun's heat hitting the icy surface. However, if this is a controlled release, distinct patterns might emerge in the coming weeks. We are looking for structure in that plume. A natural comet vents from random fissures. A hitchhiking probe using the comet as a propellant tank would vent from specific, strategically located thrusters. The sheer abundance of this hydrogen plume supports the idea that 3I Atlas is a water-rich body, an ideal candidate for what theoretical physicists call an interstellar vehicle for migration. Consider the logistics. To cross the void between stars, you need resources. You need reaction mass. Finding a rock like this, which is essentially a frozen gas station moving at hypervelocity speeds, would be the easiest path to high-speed interstellar travel for a civilization that originated on a planet as massive as Earth. You do not build a ship from scratch and push it against your planet's gravity well if you can simply catch a ride on a distinct, fast-moving object that is already supplied with millions of tons of chemical energy. The data we have from the last 32 days confirms the supply is there. The presence of 13.5 million metric tons of water released in such a short burst proves that the resources are available on the surface or just beneath the crust. This brings us to a critical divergence in scientific opinion. Most astronomers are currently modeling this as a thermal event. They are fitting the hydrogen curve to standard sublimation models. But there are subtle discrepancies in the rate of release versus the distance from the Sun that suggest something else might be contributing to the ejection velocity. If this were a simple snowball melting in sunlight, we would expect a very specific curve of hydrogen density dropping off as the object moved away from perihelion. That is not exactly what we are seeing. The density has remained surprisingly high, implying that the mechanism releasing this gas is robust and perhaps internally driven rather than just passively responding to solar radiation. We must remain cautious, of course. Extraordinary claims require extraordinary evidence, but in science, we must also follow the data where it leads, even if it leads to uncomfortable conclusions. The hydrogen plume is a smoking gun, not necessarily of technology, but of potential. It transforms 3I Atlas from a passive rock into a potential resource depot. And if it is a resource depot, then the probability that it is being utilized increases significantly. This contradicts what we previously thought about the barren nature of these high-speed interstellar objects. It is not just a rock, it is a reservoir. As we move forward, we need to look at how this intense outgassing correlates with the object's motion. Newton's third law applies potentially to aliens as well as to us. For every action, there is an equal and opposite reaction. Ejecting 13 million tons of mass has to push the object. We are now recalculating the ephemeris, the predicted position of the object, to see if this push matches natural venting or if it shows signs of something more directed. This connects perfectly to the other unexplained phenomena we have observed. The hydrogen plume is just one piece of a much larger puzzle involving the object's geometry and orientation. To understand why this fuel source matters so much, we have to look at how the object is aligned with the rest of our solar system, and that is where the coincidences start to look less like accidents and more like a flight plan. The amount of water is one thing, but the direction it is traveling is another matter entirely. This plume might be the engine, but we need to examine the steering wheel. That brings us to the strange geometry of its arrival. As we established, the hydrogen plume suggests 3I Atlas has the fuel required for propulsion. But fuel is useless without a trajectory, and this is where the new data becomes truly baffling. We are looking at a set of geometric parameters that defy statistical probability. When an interstellar object enters our solar system, it should theoretically come from a random direction. Let's look closer at the numbers. The trajectory of 3I Atlas is inclined by roughly 5 degrees relative to the orbital plane of the solar system. In the context of galactic dynamics, this is a bullseye. Imagine throwing a dart from a mile away and hitting the thin edge of a dinner plate. That is essentially what we are seeing here. Out of all the possible angles of approach, 360 degrees of three-dimensional space, this object slid into our system almost perfectly parallel to the plane where all our planets orbit. A 5-degree difference is statistically negligible when you consider the random distribution we expect from natural debris ejected by other stars. This contradicts what we previously thought about random interstellar distribution. If you were a pilot trying to maximize your gravity assist maneuvers or scan the planets of a target system, this is exactly the approach vector you would choose. You would want to stay in the ecliptic plane, the flat disk where the planets live, to minimize the fuel needed to visit them. A high inclination orbit coming in from above or below the system makes rendezvous extremely energy expensive. 3I Atlas has effectively chosen the path of least resistance for interplanetary travel within our system. But the alignment anomalies do not stop there. We have also analyzed the rotation of the object itself at large distances from the Sun. The rotation axis of 3I Atlas appears to be aligned with the direction of the Sun. This is highly unusual for a tumbling space rock. Typically, rotation axes are random. To have it pointing somewhat consistently toward the central star of the system it is entering suggests a level of stabilization that is hard to explain with natural collision mechanics. It resembles a spin-stabilized satellite more than a chaotic fragment of a planetary collision. Here is the crucial detail that the spectroscopic teams are arguing about right now. We are seeing unusual compositional traits, specifically an anomalously high nickel-to-iron ratio. On Earth and in the asteroids we usually study, iron and nickel appear in fairly standard ratios based on how they formed in the primordial planetary nebula. 3I Atlas is showing a signature that is rich in nickel, far richer than ordinary cometary outgassing models predict. Why does this matter? Nickel superalloys are a hallmark of advanced aerospace engineering on Earth. They are used in turbine blades, rocket engines, and heat-resistant casings because they can withstand extreme thermal stress. So what does this actually mean? If we combine the hydrogen fuel source we discussed in the previous segment with this high-grade metallic composition, the picture shifts. We are looking at an object that has the fuel for a rocket and the material composition of a heat shield or an engine component. It is symmetric too. The jet structure we have observed in the coma, the way the gas is leaving the body, appears surprisingly symmetric. Natural outgassing is messy. Jets erupt from weak spots in the ice, causing the comet to tumble wildly. 3I Atlas is maintaining a dignity and symmetry in its venting that implies structure or perhaps control. I want to hear your thoughts on this. Do you think a 5-degree inclination is just a cosmic coincidence, or is that too precise for your comfort? Leave a comment below with your take on these probabilities. This alignment of the rotation axis combined with the orbital plane injection creates a scenario that is incredibly favorable for the release of probes. If you are a mothership or a carrier vessel, you want a stable platform. You do not want to be tumbling end over end while you try to launch sensitive equipment. The stability we are observing would make 3I Atlas an ideal launch pad. And remember, this is all happening while it is traveling faster than 60 kilometers per second, a speed that allows for rapid transit between stars. Yet, it is behaving with the poise of a guided craft. The skeptics, quite rightly, are calling for more data. They argue that we are seeing patterns in the noise, and that is a fair scientific stance. But as we accumulate these anomalies, the statistical likelihood of them all happening on the same object by chance drops lower and lower. We have the fuel, the water, we have the trajectory, the orbital plane alignment, we have the stability, the rotation axis, and we have the material, the nickel-iron ratio. In a court of law, this would be circumstantial evidence, but it would be a mountain of it. The symmetry of the jet structure is perhaps the most visual piece of evidence. If we could see the nucleus clearly, and we cannot, it is too small and shrouded in gas, we might see vents spaced equidistantly. That is speculation, but it fits the data of the symmetric plume structure. We are forced to consider that the object's physical properties are tuned for its journey. This leads us to a fascinating, if unsettling, possibility. If this object is engineered, or at least modified, why does it still look like a comet? Why create a gas cloud? Why not just fly a metallic ship through the system? The answer might lie in the oldest military strategy in history. If you are crossing hostile or unknown territory, you do not fly a flag, you fly a disguise. To understand the true nature of 3I Atlas, we have to stop thinking like astronomers and start thinking like strategists. This brings us to the concept of concealment. Building on the idea of the high nickel content and the precise geometric alignment, we arrive at the Trojan Horse hypothesis. This is perhaps the most strategic explanation for why an advanced technological vehicle would resemble a natural object. Embedding advanced technology beneath a comet-like exterior is not just a convenient way to travel, it is the ultimate camouflage. In the Greek myth, the Greeks hid inside a massive wooden horse to infiltrate the city of Troy. The Trojans, believing it to be a harmless offering, brought it inside their walls. In the cosmic sense, our solar system is Troy. 3I Atlas is the horse. To most observers across the Milky Way, and presumably there are many, these hitchhiked vehicles would initially appear entirely natural. If you are scanning the sky for aliens, you are likely looking for radio signals, laser flashes, or Dyson spheres. You are probably not cataloging every single rock that passes by. By masquerading as a comet, a probe effectively disappears into the background noise of the galaxy. This concealment strategy reduces the risk of interference from outsiders. If you send a shiny chrome spacecraft across thousands of light-years, it attracts attention. It might be intercepted, salvaged, or destroyed by another civilization or even by natural hazards. But a billion-ton rock that is boring, that is safe. It provides physical shielding against micrometeoroids and cosmic radiation, protecting the delicate technology inside. It is the perfect wrapper for a long-duration package. This explains why we see the comet-like activity. The water and the outgassing are real. They are the shield and the fuel source, but they also serve to make the object look mundane. It is only when exceptionally perceptive scientists like the teams analyzing the Solar and Heliospheric Observatory data start looking at the fine details that the illusion falters. Subtle anomalies like the symmetric jets or the specific hydrogen release rates we discussed act as potential technological signatures. But even then, the natural assumption is to doubt. The stance of the scientific community is naturally conservative. Suggesting that a rock is a spaceship invites skepticism or ridicule. This psychological barrier is part of the camouflage. The aliens of the gaps argument is usually dismissed. A civilization hiding their probes inside comets relies on the fact that any developing society they encounter, like us, will be hesitant to declare aliens until the evidence is undeniable. We prioritize natural explanations. We bend over backwards to model the hydrogen plume as sublimation and the trajectory as gravitational luck. However, if we entertain the possibility, what would this hidden infrastructure look like? We are not necessarily talking about a hollowed-out asteroid with living quarters. We are likely looking at embedded systems, power sources, perhaps fusion or advanced fission reactors buried deep in the core to generate electricity for the water electrolysis. You would need a network of conduits to transport the hydrogen to the surface thrusters. These systems would support onboard activity that we can't see from the outside. Possible technological fingerprints on such an interstellar comet might include excess heat. Instruments like the James Webb Space Telescope are currently staring at 3I Atlas looking for an infrared signature that doesn't match the solar heating. If there is an engine running inside or a computer processing data, it must generate waste heat. Detecting a thermal hotspot on the night side of the object, for example, would be a dead giveaway. We should also look for non-gravitational maneuvers that are inconsistent with natural processes. A comet speeds up because gas pushes it. But if 3I Atlas makes a sharp turn or accelerates without a corresponding increase in gas release, that is a maneuver. That is a course correction. Deliberately arranged thruster systems would provide this capability. We might even see artificial illumination, essentially headlights or communication lasers, if we look at the right wavelength at the right time. Another possibility is the release of miniature probes. If 3I Atlas is a carrier, it might drop sensors at strategically chosen locations like near Earth or Mars or Jupiter. These would be tiny, perhaps no bigger than a smartphone, making them nearly impossible to track from Earth. But the release itself might disturb the dust coma in a visible way. The precise nature of any embedded payload would depend on the long-term ambitions of its creators. These are ambitions that could span billions of years. They are playing a game on a timescale we can barely comprehend. As with any blind encounter in a dark forest, it would be wiser for us to focus on careful observation of such an interstellar package rather than speculating wildly about the motivations of its senders. We do not know if they are benevolent explorers, resource miners, or something else entirely. We simply know that the package has arrived. The Trojan Horse analogy is powerful because it implies intent. It suggests that the arrival is not an accident of orbital mechanics, but a calculated entry. And if there is intent, there must be an intelligence behind it. But given the distances involved, who or what is actually flying the ship? It is almost certainly not a biological being. The distances are too great, the radiation too harsh. The pilot of 3I Atlas is likely something far more durable. This brings us to the pilot. If 3I Atlas is a vessel, who is at the helm? This line of reasoning motivated the provocative question posed in a recent essay: what if 3i Atlas is in fact AI Atlas? The sheer scale of the Milky Way galaxy dictates the answer. The light travel time across our galaxy is on the order of 50,000 years. That means you cannot fly this ship by remote control. There is no mission control center back home giving orders in real time. By the time a turn-left command reached the ship, 50,000 years would have passed and the ship would be long gone. Real-time guidance is impossible. Therefore, the vehicle must be autonomous. It must have a brain. But biological brains like ours are fragile. They require oxygen, food, water, and protection from cosmic rays. They age and die in less than a century. Interstellar journeys take millions or billions of years. Biological entities are far more vulnerable to interstellar hazards than technological ones. Silicon, or whatever advanced successor to silicon an alien civilization might use, is robust. It can go dormant for eons and wake up when it detects the heat of a star. Incorporating artificial intelligence would be essential for such a mission. An advanced AI could manage the complex navigation required to hitchhike from star to star. It could handle the electrolysis of water, the firing of thrusters, and the course corrections needed to achieve that 5-degree alignment with our solar system. It could analyze the data collected by its sensors and decide which planets to observe. It essentially becomes a self-driving scientific outpost. This perspective shifts our monitoring strategy. We are not just looking for a machine, we are looking for a decision-making agent. Continued monitoring of 3i Atlas over the coming months is particularly important because an AI might react to its environment. If it senses that it is being watched or if it detects a specific target of interest, it might change its behavior. It might adjust its spin, alter its outgassing rate, or transmit a signal. Discovering a vehicle of this kind might even encourage humanity to adopt interstellar hitchhiking itself. We are currently trapped in our own solar system by the tyranny of the rocket equation. It is incredibly hard to carry enough fuel to get to another star. But if we could identify a suitable passing interstellar object, a natural bus moving at 60 kilometers per second, we could board it. In practical terms, this would require delivering a payload onto a trajectory that intersects the object at very low relative velocity. We wouldn't need to accelerate the whole way to Alpha Centauri. We would just need to catch the train as it passes the station. Our payload would need to be equipped with a robust power supply and advanced technology to survive the journey. We would essentially be doing exactly what we suspect the creators of 3i Atlas have done, embedding our smart technology into a dumb rock to carry our legacy into the galaxy. We would ensure the payload's survival by digging into the ice using the comet's body as a shield. If we accept the AI hypothesis, then 3i Atlas is not just a visitor, it is a surveyor. It is a probe sent out to build a map of the inhabited or habitable galaxy. The anomalies we see, the alignment, the hydrogen, the nickel, are simply the operational parameters of its mission. It aligned with our plane to scan our planets. It is venting hydrogen to steer. It is made of high-nickel alloy to survive perihelion passes. Everything fits the profile of a functional machine. The question then becomes, is it still active? Is the AI still running? Or is this a derelict craft, a ghost ship continuing on its pre-programmed loop long after its mission has ended? The hydrogen plume suggests activity. The stability suggests control. The evidence points to a functioning system. This insight fundamentally changes how we should treat the object. We shouldn't just be photographing it, we should be trying to interact with it. Or at least we should be watching it for reactions. We need to see if it does something that a rock simply wouldn't do. We need to watch it at the next critical junction. There is a specific date coming up where the rubber meets the road, or rather, where the comet meets the gravity well. The next major milestone in this cosmic encounter is fast approaching. From the perspective of the potential AI on board, or simply from the standpoint of orbital mechanics, the date to watch is March 16, 2026. On this day, 3i Atlas will make a close passage near Jupiter's Hill radius. This is the region where Jupiter's gravity dominates over the Sun's. Using a massive planet like Jupiter for a gravity assist is a classic maneuver for any spacecraft navigating the solar system. If 3I Atlas is indeed an active technological vehicle, this flyby offers a prime opportunity for a course correction. We should be watching for non-gravitational maneuvers that utilize the hydrogen fuel we now know is available. A slight burn at the moment of closest approach to Jupiter could significantly alter the object's outbound trajectory, perhaps directing it toward its next target star with extreme precision. We need to be monitoring its position with the highest possible precision before, during, and after this encounter. Any deviation from the purely gravitational path would be the smoking gun we have been looking for. Extraterrestrial civilizations, if they exist, might welcome imitation of their methods. As Oscar Wilde famously remarked, imitation is the sincerest form of flattery. If we see 3I Atlas pull a maneuver that we ourselves would execute, it validates our own physics and engineering. It confirms that the laws of space travel are universal. If interstellar hitchhiking is indeed a common practice among technological societies, we may one day find that a natural interstellar object we choose to board already hosts alien equipment. We might land a probe on a comet only to find a Do Not Disturb sign or a welcome mat left by a predecessor billions of years ago. In that case, we might simply join our cosmic companions. There is something poetic about the idea of our AI probe sitting next to an alien AI probe, both buried in the ice of the same comet drifting through the void. We would read together the shared travel journal of a journey measured in billions of years. We could learn where they came from, what they saw, and perhaps where they are going. For now, our job is to watch. We must scrutinize the infrared data from the James Webb Space Telescope for that excess heat from propulsion systems. We must watch the debris trail for miniature probes. We must track the trajectory for artificial adjustments. The hydrogen plume detected by the Solar and Heliospheric Observatory was the opening statement. The alignment anomalies were the rising action. The Jupiter encounter in March could be the climax of this chapter of discovery. As with any blind encounter, it is better to be observant than to be loud. We do not know the intent of this visitor, but we do know that it offers a masterclass in interstellar mobility. Whether natural or artificial, 3I Atlas is teaching us how to travel between the stars. It is showing us that the galaxy is not empty. It is full of potential vehicles waiting for riders. This is a developing story, and the weeks ahead are critical. If you want to support this kind of deep-dive scientific analysis and help us keep the signal strong against the noise, please hit that like button. It helps the algorithm share this discovery with more curious minds. Keep your eyes on the stars and stay tuned. The universe is getting more interesting by the day.